Welcome to my channel once again. In our previous lesson, we treated the oxidation-reduction reaction. In today's topic, we'll be talking more of different examples as well, so that you'll be acquainted with different methods at which we can actually solve this problem. So, oxidation-reduction reaction is a very common question in JAMB and WAEC. So that is to say, I'm going to dwell more on different examples, and we'll go through past questions on JAMB so that you understand the major techniques used in this topic. So for us to understand this concept again, from the review I've had from the previous video, I got to understand that most of my students are not familiar with oxidation number and how to obtain the oxidation state of the central atom. So from the first step we're going to entertain today, we'll talk more about oxidation number of central atoms. That is to say, for instance, if we should have a compound known as this, potassium tetraoxomanganate. So how can we identify the oxidation state of this compound? The oxidation state of this compound, we're going to talk about this central atom that is involved here. So we said the oxidation state of potassium is +2, because it is +1, pardon. It's +1, it's a group 1 element. So for us to have this now, the very first law of oxidation, we said the oxidation number of any neutral atom is equated to 0. So I'm going to equate it to 0. So the oxidation state of potassium is +1. We are looking for this manganese. Let's take it to be S. Oxygen is -2 plus -2. It occurred 4 times. We're going to equate it to 0. That is 1 plus S, -2 times 4 is -8, is equals to 0. 1 plus S, when it crosses this bridge, it turns to what? +8. So we said S, this guy will move automatically to 8 minus 1 to give S is equals to 7. By so doing, we can have that the oxidation state of this compound is what? Is 7. It is now known as potassium tetraoxo, it has for oxygen, manganate 7. So we are able to determine the oxidation state of this central atom. So in a given redox reaction, if there's any change in the oxidation state of this compound, we say such chemical reaction will undergo what is known as redox reaction, oxidation-reduction reaction. So we are going to go for more examples. Let's go to more examples. So let's talk about the oxidation state of this compound, SO4 3. So this is a compound that is given to us. We say let's determine the oxidation state of this compound. So for this, I'm going to take this place as a radical. A radical are a group of atoms that come together and they react as a single entity. So in this aspect, the oxidation state of this sulfate will be taken as -2. So ion here, we want to know the oxidation state of ion, because ion exists in 2 forms, +2 and +3. So by so doing, ion here existed, it says 2. I'm going to say let's make this ion to be S. That is, we have 2 S here plus -2, which is the sulfate, equals to 3. We are going to equate it to 0. So for this now, we say 2S, -2 times this times 3 is -6, is equals to 0. Here with 2S is equals to +6. For us to have this S, we divide both sides by 2. We should divide both sides by 2. We're going to have S is equals to +3. So the state of ion here is +3. So if this compound should undergo what is known as redox reaction, if there's any change in this in the state of this oxidation number, we can understand that oxidation number of redox reaction have actually taken place. Like I've said from my previous video, a better understanding of oxidation number is the key in understanding this topic known as redox reaction. So let's have H2SO4, H2SO4. So by so doing, we're going to look for the oxidation state of this sulfate, So we said oxygen occurred 2 times. We said hydrogen, hydrogen is 2 plus 1 times 2 plus S plus -2 occurred 4 times equals to 0. You say, yeah, plus 2 times 2 plus S, -2 times 4 is -8, is equals to 0. By so doing, we said 2 plus S is equals to plus 8. For us to have S, we said 8 minus 2 to give us S equals to 6. That is why this is known as hydrogen tetraorthosulfate 6 acid. So from this build-up, we can move to different examples on this oxidation-reduction reaction. So the first of them, let's have this equation plus oxygen to give carbon oxide plus water. Okay, if you should see this kind of equation, what will come to your mind? As I've said before, you must consider this aspect of this reaction, which is a reactant. We must know the oxidation state of each of these reactants. So we said this participating species here. Let's know the oxidation state of this carbon. We said carbon here is want to know, they're going to equate it to 0. We say we are looking for the oxidation state of carbon. Let's take carbon to be S. Oxidation state of hydrogen here is plus 1, pardon. It's equals to 0. It occurs 4 times. 4 times 1, you're going to have S plus 4 is equals to 0. For us to have S, when this crosses, turn to -4. So the oxidation state of carbon in this aspect is -4. And if you should check this other side, let's have the oxidation state of carbon here. We said carbon oxide is equals to 0. We said S plus -2. It occurred 2 times. The oxidation state of oxygen is -2. It's equals to 0. We said S minus -2 times 2 is equals to 4. So here we said S is equals to plus 4. So carbon moved from -4 to plus 4. So we are going to talk about the other reactant. The other reactant, we said oxidation state of a free uncombined element is 0. Here, the oxidation state of oxygen in a compound is -2. So oxidation state of oxygen, this is for carbon. Oxidation state of oxygen move from 0 to -2. By so doing, we say that if the oxidation state of a participation chemical element increases, when it increases, it is known as oxidized. It has been oxidized. We said this methane gas here has been oxidized. While this has been reduced from 0 to -2. So an oxidized part of a chemical species in redox reaction is known as reducing agent. While the reduced part of it is known as oxidizing agent. So by so doing, from this a given equation, from this to this, say it undergo what is known as oxidation reaction, loss of electron. So while from this to this, or both can say it undergoes what is known as a reduction reaction. So from our previous lesson on electrolysis, we said in reduction reaction, these atoms, they acquire electron. So let me just point this out. In your SSC exam or JAMB, you might have question that comes about oxidation and reduction. So if peradventure you have the electron at the left hand side or the electron at the right hand side, you should know what to do. So we're going to use a very good example to illustrate this aspect. So by so doing, the methane gas in this aspect is a reducing agent, while the oxygen here is the oxidizing agent. So let's use a very good simple equation to explain, to bring out this oxidation and reduction for easy understanding. So let's say have chlorine to have sodium chloride. So if you should have equation like this, like I've said before, okay, let's place this aqueous. Let's have this now, that if we have an equation in this manner, if one should ask you what is the oxidation, the reducing agent and the oxidizing agent, we said we're going to know the oxidation state of each of these participating reactants. So what will come to your mind as a student during exam condition, just look at the reactants. That is where your concentration should be, so that you know what is reducing and what is increasing in oxidation. So in this aspect, we said the oxidation state of any free element is 0. Oxidation state of any free element here is 0. But in this aspect, we have, since it's a plus 1, this is a negative. As I've said, this is a group 1 element, this is group 7. So it needs only 1 electron to be ordered to have 8 electrons in its outermost shell. So by so doing, we said sodium now move from 0 to +1. Why chlorine move from this is for oxygen, this is for sodium, this is for sodium. For chlorine, it moved from 0 to -1. Like I've said, the -1 is smaller compared to the 0. So that is to say, this one that increases in oxidation number, we say this part of it has been oxidized. While this part that is reduced from 0 to -1 is classified as reduced. Oxidation number have reduced. So the part of this chemical reactant that got increased is known as what? A reducing agent. Why this aspect that got reduced is known as oxidizing agent. We said this part that moved from here to this is known as oxidation reaction. Why this that move to this is what known as reduction reaction. So if peradventure, if you should say which of the following equation represent oxidation and which of them represent a reduction reaction. By so doing, if we should have sodium, for instance, when sodium since undergo reduction, I'm going to have sodium ion when it gives us an electron. So if this electron is found at the right hand side, most of the time it is known as what? Oxidation reaction. Just for multiple choice question. So instead of stressing yourself, you can actually say that if there's an electron at the right hand side of any given equation, such aspect of chemical element undergo what is known as what? Oxidation reaction. So we said chlorine when it acquire an electron, turn to what? Negative chloride. So by so doing, if we should have a simple illustration, if we should have this electron at the left hand side, okay, let me emphasize this. Let me emphasize this properly. As I've said, for reduction reaction like this, to have we said if we should have this electron at the right-hand side of a given equation, such reaction and undergo what is known as oxidation reaction. For multiple choice question for JAMB students. So if we should have chlorine that they acquire an electron, can say if this electron is found at the right-hand side, at the left-hand side, I mean, the left-hand side, we say such chemical element have undergo what is known as reduction reaction. So for multiple choice question. So from this point, I'm going to move to, let's have a more complex equation. Let's have a more complex equation. A more complex equation. So let's have something like potassium iodide plus ion SO4 3 to give a potassium 2 SO4 plus ion SO4. All right. So if peradventure you are given an equation in this manner, so you are given an equation in this manner. Let's say you have a given equation like this plus iodine plus iodine. So if you are given a given equation during a multiple choice question, as I've seen here, if you should notice this aspect, we said this is you are asked to identify a reducing agent and oxidizing agent. How can you perform this? So because of your time during a multiple choice question, you will notice a very simple equation here. You see this reactant. We said when classifying this, you should look out for this reactant at the left hand side. So by so doing, if during the exam condition, you can actually look out for the oxidation state of this potassium iodide and this iodine. So this is the simple one that you can actually obtain for multiple choice question. For this now, you have plus here, we have negative here. So by so doing, we have iodine here. Iodine here move from -1 to plus to 0. It moved from -1 to 0. So if we should compare this ion here, let's say this ion here, it moved from let's have the oxidation state of this compound under exam condition. Under exam condition, I will teach you how to manipulate this, but let's have the oxidation state of this compound. We said we're going to know the oxidation state of ion. We said let's make ion to be S. It occurred 2 times here. Plus, let's use this as a radical. We said -2 to -2. It occurred how many times? 3 times. Is equated to 0. We said 2s here plus -2 times 3 is -6. Is equals to 0. We said 2s plus, okay, let's just equate it. It's equal to plus 6. We said s here is equals to 6 divided by 2. S is equals to 3. So the oxidation state of ion here is 3. So by so doing, let's look at the oxidation state of this ion here. We said F SO4 is equated to 0. We said ion here, I'm going to take it to be S. Oxidation state of this is -2. Let's take it to be -2 plus -2 is equals to 0. By so doing, we said S is equals to 2. So oxidation state of ion here moved from 3 to 2. But for multiple choice question during exam condition like JAMB, well, we advise my students that they should look out for this simple potassium iodide. Since there's automatic, it moved from -1 to 0. You should understand that this now is increasing. It moved from -1 to 0. There's an increase in oxidation number. So by so doing, you can equally automatically say that this has been oxidized. because of your time during exam condition, under any part of the chemical reactant that is oxidized, is known as what? Reducing agent. It's known as reducing agent. So why this that is reduced from 3 to 2 is reduced? It's already reduced. This part of it is known as oxidizing what? Agent. Oxidizing agent. So most of the time, looking at this some equation, just focus on a specific reactant so that you know whether such reactant reduced in the process or increased. So by so doing, you can actually work out this simple aspect of the reactant so that you can use it to infer the reducing and the oxidizing agent in the chemical element. So from this now, having gone to this point, we're going to introduce some questions from JAMB so that we answer 1 or 2 questions from JAMB on how they can be able to solve this issue during exam condition. So by so doing, let's take exam questions from JAMB. Exam question from JAMB so that we know how this question has been, how they will appear during your exam that is coming up next month. All right, let's take some questions. They said one of them said, let's have MO2. Said MN4 NO4 plus S2 plus 8 hydrogen ion to give manganese 2 plus S plus 4 mole of water. So the question goes this way. The oxidizing agent in the above reaction is dash. The oxidizing agent in the above reaction is dash. So what concerns us is this aspect of this equation. So we're going to compare this and this. Look at this one now. This one move from negative 2 to 0. This move from okay, oxidation state of this is manganese. Let's say S. Manganese, don't know the oxidation state of manganese here. I say plus oxidation state of negative of oxygen is negative 2. It occurs 4 times is equals to 0. Here S plus, let's say negative 8. Negative 2 times 4 is negative 8 is equals to 0. S is equals to 8. It's equals to 8. But if you check here, the oxidation state of manganese here is 2. So it moved from 8 to what? To 2. By so doing, this aspect of it got reduced. While this negative 2 to a metallic sulfur. A metallic sulfur that uncombined is equals to 0. Here is negative 2. Here it moved from negative 2 to 0. Please don't be confused with this 0. So when you are plotting a graph, as I've explained before, if you should have an origin here, this part of it is negative S, positive Y, positive S, negative Y. So by so doing, if you should have any negative here, it will come to the origin before you come to the positive end. So any negative sign, 0 is bigger than any negative sign. That is to say, this side is reduced, this aspect of it got oxidized. So by so doing, we said this side that is reduced in the process, and the side that is reduced, we said the side that is oxidized is known as reducing agent. Why this aspect that is reduced is known as what? Oxidizing agent. So with the option, it said A, sulfur 2 minus and manganese 2 plus, B, manganese 2 plus, C, manganese ion, D, sulfur and hydrogen ion. The answer will be what? Oxidizing agent will be what? will be manganese. Will manganese. Will be manganese or ion. Manganese ion. So for us to identify this now, we'll say which of the other question will go this way. In which of the following process is ion being oxidized? In which of the following process ion is being oxidized? Ion is being oxidized. Ion is being oxidized. So we're going to have the equation. We said one of them, we're going to have F plus, say this is A. We are going to H2SO4, H2SO4 to give ion SO4 plus hydrogen. We said B, FSO4 plus hydrogen sulfide, to give iron sulfide plus H2SO4. H2SO4, we said B. We said that we have B. FeC2 plus chlorine gas to give 2 chloride. We said the D part of it, D, we have so FCl3, CF2L3 plus SN2 to give FCl2 plus SN10 chloride. Okay, so which of them, let's take this to be number 1, 2, 3, 4. So which of them, the question go this way, in which of the following process is ion being oxidized? Ion being oxidized. So they want to know which of them ion is being oxidized. I'm going to analyze this in a very simple manner. We said the question 1, look at this. We said oxidation state of ion, if free ion is 0. From here, ion here is +2. That is, it increases. That one increases. Here, we say ion here is +2. Ion here is in hydrogen sulfide. Sulfide is -2. So ion here will be +2 as well. So here, ion here, I'm going to have it's going to be +2 as well. Going to be +2. Here, ion here will be 3 +3. +2 to +3. This is 2, 2. Here, ion here is 3 as well, because here we have -1 of the chloride times 3. When it crosses the bridge, ion here will be what? Will be +3. So here, ion here, -1 times 2 Negative 1 times 2 is negative 2. So when it crosses, it returns to what? Plus 2. So which of them is oxidized? They said A. They said A. They said A. 1 only. B. 2 only. C. We have 3 only. 3 only. D. 1 and 3. 1 and 3. So from this now, what can we say here? We said any part of a given equation that is oxidized, you now understand that any part of the equation that is oxidized, there's an increase in oxidation number. There's an increase in oxidation number. There's an increase in oxidation number. So for this equation, oxygen moved from negative 0 to plus 2. There's an increase here. Here, there's no increase here. Here, ion moved from plus 2 to plus 3. There's an increase here. Here, there's a decrease here. There's a decrease here. So by so doing, option D is the answer. So this is how you try to summarize these options so that you can cancel out for multiple choice question. You can actually cancel out the ones that is only there. When you are left with 2 options, you should be able to get the correct answer. So we are going to look for more questions. So we have okay. So we have look at this question. This talks about oxidation number as well. So we have so many questions on redox reaction. Please do well to read your textbooks and go through different questions so that you know the techniques at which they use to set these questions. So we are going to take the last question. Let's take the oxidation number of manganese in MO, in oxidation state of manganese in MO, and MnO2 respectively. The oxidation number of these respectively is, so the oxidation state of this, we said oxidation state of any compound is equated to what? To 0 of a neutral compound. We said the oxidation state of oxygen here is negative 2 equated to 0. Manganese is equals to what? Plus 2. Here we say manganese negative 2, it occurs 2 times, plus here. There's a plus here. There's a plus here. No, there's a plus here. So we have negative, oxygen occurs 2 times, it's equated to 0. Mn is equals to negative 2 times 2 is equals to 4. So by so doing, we say oxidation state of manganese in this version is plus 2, and here is what? Plus 4. So the option goes this way. A plus 2 and plus 2. Said A plus 2 and plus 2. B plus 2 and plus 4. C plus 4 and plus 2. D plus 1 and plus 2. So from our calculation, we say plus 2 plus what? Plus 4. B is the option. So if you should have any problem with oxidation-reduction reaction, please do well to comment on the comment section so that we can know what to treat. So during the course of your preparation for your JAMB, please, if you like this video, do wait to share and subscribe to this channel. Thank you very much.